Good morning, students. Today we'll discuss that f of z be a function. That f of z be a function with the continuous second order partial derivatives. With the continuous second order partial derivatives, then del square f of z. Del square f of z is equal to 4 into dou square by dou z into dou z bar f of z. 4 into dou square by dou z into dou z bar f of z. In this case, del square is equal to 4 into dou square by dou z into dou z bar. By using these results, we can do one problem. If f of z is analytic, show that the first result is del square modulus of f of z whole square equal to 4 into modulus of f dash z whole square. The second one, del square log modulus of f of z equal to 0. Third case, del square log modulus of f dash z whole square equal to 0. All these three cases we can prove by replacing del square by 4 into dou square by dou z into dou z bar. Then we can do the first problem. The first problem, del square modulus of f of z whole square is equal to 4 into dou square by dou z into dou z bar modulus of f of z square. We know that modulus of z square equal to z into z bar. Therefore, modulus of f of z square is equal to fz into fz bar. Therefore, modulus f of z is equal to f of z bar. F of z into f of z whole bar is equal to modulus of f of z square. That is equal to 4 into dou by dou z bar f of z into f of z whole bar. First, we differentiating f of z into f of z bar with respect to z bar. With respect to z bar. Then we get 4 into dou by dou z. Then that is equal to f of z into f dash z whole bar. F dash z whole bar. Then again we differentiating with respect to z. First we differentiating with respect to z bar. Then we differentiating with respect to z. Then we get 4 into fz. Fz is equal to f dash z. F dash z into f dash z whole bar. That is 4 into f dash z into f dash z whole bar is equal to modulus of f dash z whole square. Modulus of f dash z whole square. Therefore, first result, del square modulus of f of z whole square is equal to 4 into modulus of f dash z whole square. Here, first we replace del square is equal to dou square by 4 into dou square by dou z into dou z bar. Then modulus f of z square is equal to f of z into f of z bar. Then first we differentiating with respect to z bar. First we differentiating with respect to z bar. Then f of z into f of z bar, it becomes f of z into f dash z whole bar. Then again we differentiating with respect to z. Then 4 into f dash z into f dash z bar. That is 4 into modulus of f dash z whole square. That is the first result. Then we can do the second result. Then we can do the second result. Second result, del square log modulus of f of z. This del square is equal to 4 into dou square by dou z into dou z bar. Then log mod of z. Log mod of z is equal to log fz bar whole raised to 1 by 2. Fz bar whole raised to 1 by 2. Fz into fz bar whole raised to 1 by 2. Then this is first we differentiating with respect to before that 4 into dou square by dou z into dou z bar into log ab. This can be written as into 1 by 2 log f of z bar. F of z into f of z bar. This 4, 2 cancel, therefore this is equal to 2. This is equal to 2 into dou square by dou z into dou z bar into log AB. Log AB is equal to log A plus log B. Therefore, log A, log f z plus log f of z bar. Log f z plus log f of z bar. That is equal to, first we differentiating with respect to z bar. That is 2 into dou by dou z of, first we differentiating with respect to z bar. The first term will be 0 plus, then in second case 1 by f of z bar into f dash z bar, 1 by f of z bar into f dash z bar. Then we differentiating with respect to z. Then we differentiating with respect to z. This is z bar and this is z bar. Therefore, the answer will be 0. When we differentiate partially with respect to z, the net result will be 0. This is the second result. Therefore, in the second result, mod f z can be taken as f z into f z bar, whole raised to 1 by 2. That is 1 by 2 into log f z into f z bar. Then log AB, log A plus log B. Therefore, 2 into dou by dou z of, when we differentiating with respect to z bar, in the first case will be 0. The second case will be 1 by f z bar into f dash z. Then we differentiate with respect to z, the answer will be 0. That is the second result. Then we can do the third result. Third result says that, del square log f dash z whole square. That is, del square is equal to 4 into dou square by dou z into dou z bar. That is log modulus of f dash z. Modulus of f dash z square is equal to log f dash z square is equal to f dash z into f dash z into f dash z bar. Log modulus of f dash z square is equal to f dash z into f dash z whole bar. That is equal to 4 into dou square by dou z into dou z bar log f dash z plus log f dash z bar. Log f dash z plus log f dash z bar. That is equal to, first we differentiate with respect to dou by dou z with respect to z bar. The first term will be 0. In the second case, 1 by f dash z into f dash z bar. Then we differentiate with respect to z. Here z bar. Therefore, the final answer will be 0. That is the third result. The third result, del square log modulus f dash z whole square equal to 0. For that, mod f dash z whole square is equal to log f dash z into f dash z bar. That is log AB. Log AB equal to log A plus log B. First we differentiate with the z bar. The first result will be 0. The second result will be 1 by f dash z into f dash z bar. Then we again differentiate with the z. The answer will be 0. This is the third result. Therefore, by using del square f of z equal to 4 into dou square by dou z into dou z bar f of z, we can verify these three results. First result, del square modulus f of z whole square equal to 4 into modulus f dash z whole square. The second result, del square log mod f z equal to 0. Third result, del square log mod f dash z whole square equal to 0. That is the result. Okay.